Every AI coding tool you've ever used is just a loop with a model in the middle. Companies that make those models, they want you to use the expensive one. That's how they make their money. Nobody's incentivized to make the cheap one win, except me. Here's a simple test. You can see the open source version versus Claude Code. I actually made Claude Code a little easier because I used Sonnet. And you can see, for small tasks, the cheap open source models already win, right? For the larger, more complicated tasks, that's not the case, and that still needs some improvement. I will be working on that over the next couple episodes. But the market just needs an honest answer. Like, why spend so much on these super expensive models from all the big closed providers? Is it really the best use? A quick disclaimer before we go on. I'm about to tell you my resume, the single most narcissistic thing that you can do on the internet. But I'm going to do it for an important reason. I want you to stay with me on this journey, and I want you to realize that this guy isn't coming out of nowhere. He actually does have some background that qualifies him for this challenge. I started programming when I was 7. That's been about 42 years of never-ending programming. In high school, I ran the IT department for the school district. At college, I worked at the IT department for Virginia Tech. Then I went on to Microsoft. You've used some of my products. I worked on Windows XP. I built the taskbar. So if you've ever grouped some taskbar icons together. I also worked on an amazing project called the Kin phone. Go look that one up. Interesting success case. That was while I was working in the China office in Beijing. After that, I moved to a local Chinese tech company called Qihu Sanliuling. There we built Koxing, which is a competitor to this little-known product called WeChat. Then I came back to the US, Amazon, Meta, video integrity, a whole bunch of AI classifiers for determining which videos are going to cause us a lot of trouble. Worked on a couple startups, consumer products like Dispo and Bubbly, health insurance ones, CXA, in various countries, Singapore, US. Dispo, widely successful social media app. We got up to 80K rev and monthly. So done the startup, done the large company, done AI, done China, definitely done coding. So I'm not some YouTube influencer just trying to get by. This is what I do. I may be in the basement, but I know how to write software. Cool. I've laid down the gauntlet. I've challenged Claude CLI. I'm going to beat it. Now let's see how, okay? And judge for yourself whether or not this makes any sense. All right, let's break this down. First step, harness. This is Claude CLI, Claude Code. That's what you're familiar with, okay? Then there's the IDE, normally VS Code. All right, then there's the platform. Platform gets a lot less attention, all right? That's gonna be varying depending on which product you're building. All right, first step, let's look at the harness, because not everyone here is gonna be totally familiar with exactly what that means. All right, so what a harness actually is, okay, is a chat. Right? It's no different than you open up ChatGPT and you're having a conversation. It's just the nerdiest conversation you can ever have, okay? Very first thing that's sent is this long description of all the little tools that you can use. So read, edit, bash, grep, whatever, right? Just this description. It's like, you should do these things. And in fact, these things are insanely long. They're like 30,000 characters, okay? Then the model replies and says, cool, I love all those options. I'm going to run bash and run it with these commands. That's it. It's just a chat reply, okay? Takes the response, the harness it runs the command, whichever one it executed, in this case bash, takes the result, hands it back as yet another chat message. That the AI chat responds and says, okay, now call this other tool called edit, change this file, and replace this string with this other string. Finishes that, returns no errors, and then it's done. And that's a very simple compile, edit, loop, okay? And you can imagine with all the different tools that it can use, it can do lots of different things. Now, this is how Claude Code works. This is how OpenClaw works. This is how this is agentic program. This is what that is, okay? Nerdy chat. Step 2, the IDE. So we're all familiar with VS Code. Okay, this is where it exposes a set of tools that can be used by the coding agent or the harness, okay? In the example of open code, that one exposes approximately 11 tools. It's a fairly simplistic open source product. You can go look it up, see how it works. Claude Code, it exposes approximately 27, well, exactly 27. And the current Ugly Studio design, as I have it spec'd, is at 34. The exact quantity is not super important. This is just like an example. So here's a list of some sample ones. You can see a lot of ones you're familiar with, the read, writes, edits, multi-edit, bash, standard stuff, okay? This is a pretty comprehensive. There's a lot of overlap between them, all right? So you can see here's your standard like file mutation ones, read, write, edit. Here's your standard like execution and search functionality. These are really the nuts and bolts that you see most of the time. And here's some of the standard, more advanced operations that you'll see people use, okay? There's a bunch in here you won't recognize because they're probably specific to Ugly Studio, and we will get to them in following videos. So you can see as I'm progressing through this design, but just give you a hint, this is another big layer for competing. Last one that's not exploited as much as it honestly should be. It's the framework or the platform or the API, whatever you want to call it. You could think of this as like React or Next or something like that, okay? So your normal app, you can imagine, it shows some like web page, right? I have a little sample here, image gallery, okay? So what this thing does, the platform or the framework that I've built specifically exposes these events so they can be used within the IDE and the harness so that data gets funneled back into it in a trivially simple AI optimized format, right? So it doesn't require advanced reasoning to understand that a click occurred. It's a clear event, okay? I don't stop at simple events, right? You can imagine you can turn queries on the events and all these, you saw Python execs, some other advanced operations in the previous one. Not only do I do events, screen cap, right? So your typical way that you would determine if an app looks good is you do a little screenshot, feed it back into the AI, ask it questions and say like, does this look pretty? Or the buttons are in the wrong place. It's incredibly hard for AI to take an image and figure out where a button is at. So yeah, I'll do the screen capture. That's basics, okay? But what's more important is the structured output with clear IDs that it can find in the code to link this button is in this hierarchy and this is where it's located. That's the thing that gives the AI the ability to quickly solve problems without burning tons of tokens and without needing a super brain, okay? These are the steps. I'm gonna apply this collection of skills with a whole bunch more tricks I'm gonna get to in later episodes to finally beat Claude CLI running Opus, which will be incredibly challenging because, to be honest, that's a moving bar as we're producing this. I think 4.8 just came out yesterday. So wish me luck. Okay, here's the bet. I'm not going to cherry pick any of my results. I will share with you exactly what I do. I will share with you how much it's costing me. I'm going to use a mix of my own personal coding tests along with some public ones from Sweetbench and other sources, so you can see the compare and contrast. I'm going to do some demonstrations, which are more subjective, right? Does this produce something that looks good? And I'll share with the product. You'll be able to use it on the website. Determine for yourself what you think. Everything I make, you can go download on the internet. I'll have the GitHub repos. You can try my app. Use it if you want. It's all public. Nothing hidden. No secrets. You'll see it all. That is what I can promise. I can also promise that there will definitely be some videos that will show me failing. This is not a particularly easy task, and there will be some challenges. Let me introduce you to Ugly Studio. This is the IDE that I built for this particular challenge. You can download it on the website, ugly.bot/studio. Give it a try. Should work Windows, Linux, Mac. Cool. Point of this isn't to sell you product, but feel free to try it out. I spent a little time on this. All right. This thing, for today, we're going to keep it really simple and just focus on some eval tests, but that should give you a good exposure to how this is going to work. All right, so I have this little button over here, run eval. You can see I've already done some test runs. Let's kick one off. So short-algo-topo-sort-cycle. This is a pretty basic, simple coding test. Not expecting any of the AIs to struggle here. And we're going to go crazy cheap, and we're going to start with DeepSeek V4 Flash. All right. Let's start here. And we're off to the races. Let me hide this. Make it a little more focused. All right. So if anyone has used a coding harness before, like Claude Code, Codex, the like, you'll recognize this. This is all the little commands getting executed. Ugly, my project here, very focused on transparency. So you can see every single thing going back and forth. It's not trying to hide anything from you. Hope you like the color coding. Spent a little bit of time on that. That was fun. And I think we are at a conclusion. All right. So I'll highlight up here and here. You can see the token distribution. So we'll get a final number as this thing kind of finishes up. Perfect. All right. We hit grade run. Awesome. Total time 1 minute 37 seconds at a total cost of almost 1 penny. 375,000 tokens in, 5.8K out. Okay, again, this isn't one that's going to break anyone. This is kind of standard market. And the other thing I want to highlight here, not everybody spends as much time focusing on token counts as I do. What's really important for optimizing your cost structure is maximizing cash read. So if you go look at that, you can see 52K in, 322K cached. So you got to structure your prompts to ensure maximize cash token reads. Drastically lowers the cost. A cash token costs like a tenth what a normal token cost. I mean, these are already obscenely cheap, but save money as much as you can. Why not? All right, let's kick off another one. Run eval. There we go. This time, we are going to run in Opus. Not only in Opus, we're technically not going to be using my harness for this one. This one uses the Claude code harness or Claude CLI. I wrap it in this UI just to make it consistent so it's easier to film. So you can see the same colors and everything. But this is literally the exact same tools and prompts and everything from Claude CLI. It's literally just calling it and just proxying the JSON data around. All right, so very exciting stuff. All right, so you can see I'm caching all the telemetry data as it goes. So you can see we've already far exceeded the cost of the DeepSeek one, which was 1 cent. Here we're just warming up and we're already out at 11 cents. So looking pricey. And you probably won't be surprised by the end of this. Opus is able to figure out the solution to this particularly challenging problem. In previous runs, it usually also was about a minute. So I expect something similar this time. Ooh. Yeah. These things always have to guess at how to talk to the command line. So it's not uncommon for them to make the wrong assumptions about how to execute TSC. But both environments were the same. I promise. All right. All right. Let's grade it. Boom. Took a little longer. Sometimes it's faster. This time it was a little over 2 minutes at a cost of 45 cents. That's ridiculous. Like that's almost a pack of gum. So you can see also the token counts is actually higher in this case, which is interesting. Oftentimes it's the other way around. The token count tends to be higher on the open source ones than on these ones. But I think as we progress into harder problems, we'll see that change. All right. So hands down, straight up win for DeepSeek on this one. Pretty much any of the open source models would have been able to crush this one. This is a fairly simple test. All right. I just wanted to give you guys a little teaser today. We'll come back and do some more interesting ones as the series progresses. Cool. So we just did a quick little test there so you can see how this thing is progressing. hopefully that was a little taste, and they'll bring you back for some more. I think I just would like to kind of close by emphasizing why I feel like this is so important. Okay. I think in the industry right now, we're all feeling a lot of anxiousness as we're learning and adapting to AI's role in the space. And I think it's important that in this time that we don't trap ourselves in a new series of closed source products that are going to be enshittified and a terrible environment for all of us. I would much rather think of this as the world of compilers. And in that scenario, I'd much rather be using GCC than any of the paid options. And that's where all the open source gives us. And if you look at the open source right now, I can go off and buy a super expensive desktop computer. It's like 5K, but I could run one of the very high-end models on my own local equipment. That stuff, all that hardware, that stuff's dropping at about a 3x rate per year. So it's not going to be long before that capability of running it locally is something you can put in your laptop. And that's scenario, I want an open source product that I can put in my laptop and run it there. I may not have a job, but at least I won't have to pay for coding. It's looking ugly out there. So I wish you all the best of luck.